Welcome to Developer Highlight number 5. With me today I have David from Synthetix. How are you?
Hey, I'm great. Thanks for having me. Excited to be here.
Yeah, excited to have you on. Why don't you just start with telling me a little bit about your story with Web3 and Synthetix?
Yeah. So I was working at Nash Social, which is a decentralized exchange for a while, and it's a cross-chain platform, and I really wanted to work on Ethereum. So it was maybe a couple of years ago, I started researching Ethereum more heavily, and I just fell in love with it. It's such a cool project, great community. I ended up going to ETH Denver and met so many cool people. I talked to the Graph while I was there. I knew it was going to be a successful project just because the team was so on top of things, and it was such a great vision. Yeah, anyway, I ended up working for Synthetix, and Synthetix is a project that I've been invested in for a while. I'm just a big believer in the vision and the model and the focus on decentralized governance and the community behind the project, because I really think community is so important. That's why I'm happy to be here, happy to support the Graph community. I think they've done a great job in building out the curator program, which I was a part of. And just like, I think you guys are doing all the right things. So yeah, I joined Synthetix. Synthetix is a protocol where you trade derivative contracts, and what that means is like you will buy synthetic ETH, which tracks the price of ETH, but it's not actually, you don't actually own the asset itself. So we get our price feeds from a protocol called Chainlink. And what we do is we allow traders to buy in and out of these assets based on the current price. And one of the benefits of that is if you are a large trader, you won't have any slippage. So on a typical exchange, there's like an order book, and you place your order. And if you have a really big order, the price will move with your order because there's only a limited supply of ETH out there. But when you're just tracking the price of ETH, you can buy as much as you want because you're not actually buying any ETH. You're just entering into a contract with another party. Yeah. So Synthetix derivatives markets are actually much bigger than spot markets where you buy the asset itself in traditional finance. And I think we'll see that trend continue with in terms of decentralized finance. Synthetix is about to launch on L2. And well, we have been launched, but we're about to launch trading soon, and we're going to add a lot more product features on Optimism. So I think, like, in terms of our usability as a protocol, it's about to become much better for a user experience, much more affordable. You can have more arbitrage trades, and futures are coming soon, so you can do leverage trading on Synthetix. Yeah, really excited about that. Anyway, as part of the Optimism push, we need to have subgraphs on Optimism now in addition to mainnet. So it's been quite a journey figuring out the best way to not only support mainnet Optimism, but also Covan and Optimism Covan, so that as we're developing things, we can test them. Having testnet subgraphs, it's ideal, but it's a little difficult because now for each subgraph you have, we actually have a lot of smaller subgraphs, which is different for most protocols. We now have 4 subgraphs one for each network, right? Because each network, you have your own, every contract has a different address on each network. So you need 4 YAML files, which is a little tricky to maintain, especially if you have we have some YAML files that are thousands of lines of code. So we spent a lot of time working through these types of problems. And yeah, when I get into the subgraphs in a little bit, it'll be more clear why we did what we did given our problem set. Yeah.
Yeah, that's great. Let's dive into it.
Okay, cool. So let me share my screen. 1 second. Okay, can you see this? It says Synthetix subgraph here.
Yeah.
Okay, so this is our repo. Before I dive in, I just want to cover some high-level things. First of all, we do have like I believe 13 subgraphs right now. If you go in the README, let's see, open preview. Yeah, so like general exchanges, rates 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And a lot of these live on every network. Some of them are only on mainnet because we're not putting that code on Optimism. But yeah, you can see that we have a lot of subgraphs. We have a lot of networks that we manage. And the reason why we did that is because if you look at PancakeSwap, they were having a lot of problems syncing their subgraphs because they just had so many transactions going through. And on Optimism, we have similar concerns where like we're just going to have a lot of traffic coming through, a lot of transactions, and we want to make sure if there's a problem with a certain area, say like maybe our loans gets hit with a lot of transactions having problems syncing with the network, all the other subgraphs are fine. And then we can maybe isolate the problems within loans, split that up further. So it's kind of like a microservices approach to subgraphs, which is not necessarily what other teams are doing. And we're actually kind of still talking to the graph, making sure this is the best way. We might combine some of them because you don't curate on the Synthetix account, you curate the individual subgraphs. So there's a little bit of game theory, there's a little bit of new things to consider here, but in terms of like what we felt like was the best starting approach, this is what we went with. It'll evolve over time. We're not on the decentralized network yet. We're looking to be on there in the coming weeks. So we actually had a meeting with the graph team today, and we're still kind of sorting out the best way to move forward. But yeah, like one of our subgraphs on global debt uses a block handler. So that specifically we like having in its own subgraph, since block handlers tend to be a little bit slower and we don't want it to affect our other graphs. But yeah, in terms of what we did, there's probably the biggest change between our subgraphs and other subgraphs is that we don't use YAML files. We use JavaScript files. So you can see it's the same fields basically that a YAML file has, but it's auto-generated using JavaScript. And we actually did a PR to the graph CLI. So right now we're using a specific commit where they merge that. I don't know if it's even publicly available yet. You might need to actually point to the one. We had a separate PR so that the graph CLI will parse JavaScript in addition to YAML that we submitted. One of our contributors named Daniel on the Synthetix team did that. He's working with me on the subgraphs, doing a great job. So yeah, so in Synthetix, when we build our smart contracts, we create a versions file. And what that versions file does is it creates for each network, each of the 4 networks that we support, which are Optimism, Mainnet, Covan, and Optimism Covan. We have a list of contracts and the name of the contract, the address of the contract, and the time it was deployed. And so what we do is we kind of map over those files. So you can see here, get contract deployments is a utility function, which basically reads from those version files and then it maps over like anything with this name in the contract for that network, right? And it creates the YAML file, but in our case it's JavaScript. So we pull the address and the start block using this this helper method, and basically in the end it's all this stuff here goes under this manifest, right? So it's very similar to the YAML file. It just looks different and weirder because it's built from JavaScript. But it's the same output, and what you get from this is, using our build script, we can now generate, if I do something like what this does, I can run npm run build all rates, or npm run build mainnet rates, and it'll run through this script, and it'll run the graph codegen command, and it'll run the graph build command, and then we have a separate script that will deploy it. So we did some shell scripting. It's a very unconventional repo for the graph, but we like it because it makes it very trivial to basically support all 4 networks. And for some of them, I would say it's a little unnecessary. Like if it's just a small subgraph like our depot one, we could have just stuck with the YAML one, but since our whole code base is like this, in our old code base, the rates YAML was like probably a couple thousand lines of code. And the reason for that is the way that Chainlink handles their rate updates, the events in their contract, we have to hard code in every proxy and every aggregator they add. So we were continually adding to the YAML, redeploying it. And so one of the biggest challenges for us was to figure out, like, okay, how do we improve our Chainlink contracts? And we actually found a way to do that using data templates. So when we refactored into this new subgraph format with the JavaScript, we started using templates for the rates. And what that does is basically it allows us to track all the contracts that Chainlink has so they can add a new aggregator or proxy contract. And I might have to go into a little bit more detail on what that means. But basically it allows us not to have to manually update or redeploy, and it'll just within using the graph itself will auto update those things. And it's actually a very tricky problem.
For other users that are also looking to deploy on multiple networks, why would you use this JavaScript method instead of using templating, using like Mustache or a simple templating engine?
Right. So actually, we were using Mustache in our original set of subgraphs. This is the newer version that's we're working to push this to replace our older subgraphs. We're not quite there yet. But I was using Mustache originally, and Mustache is great, but JavaScript's a lot more powerful, right? So Mustache, you're always like, okay, I need to like pipe things in a very specific way. I need to, auto-generate this YAML file in the right format, and like you have all these edge cases. It gets complicated once you have more advanced subgraphs, and so we really like JavaScript because it allows you to do cool things like, you just do it, you map over the templates and you replace something, right? Like a file that it points to. And it's just so much cleaner and more powerful. We have this entire utility file for the network where it's like, there's all these things we can do. So we, like I said, within Synthetix here, let me actually just show you what that file looks like. for each network, we have a file like this. It's a JSON file, right? We call it the versions file. And so each time we have a release, it has a version number, and then it has all the contracts inside of it, what address, what address is for that contract. Is it the current contract or was it replaced? So let's see, if you go up here, all of these are current, but let me see if I can find, see replaced, right? So it'll tell you which version it's now replaced by. And so we have like all of the exchanger contracts we've ever launched inside of this, right? Inside of this file. And so what we do is we map over that, and we have those files for each network. And so I think one of the things is like making sure that your backend smart contract development allows you to have these like sources of truth for your contracts, because it makes it really easy now for us to like, we call this function, which basically you pass in. So if you go back, let's see, where were we? I'll show you. Let's see. No, here. Okay. So you can see collateral short, get contract deployment collateral short. What that does is it calls this thing with this contract name, and it gets, so we pull that file for that network, right? So we pass in the network and we say, we give us the versions file, right? And so this is all of that data I just showed you is in this versions info. And then we pass in the contract name. And so it'll map over the contracts and say, give me all of those contracts, right? And then what we do is so now we have on each network, we have a history of all of the exchanger contracts. We know what their addresses were, and then we get the start block here, right? This is some JavaScript logic to get the start block. Yeah, so we get the start block and the address off that file, but if we didn't have that file, we wouldn't be able to do this, right? So what I'm getting at is your backend smart contract developers have to keep track of their changes over time in some sort of JSON file, which should be pretty manageable for them, right? Like as they're creating releases and deploying, they add to the bottom of the file with the new data, right? Because like Synthetix uses a proxy system, meaning that we don't just release everything and it's done forever. We're constantly iterating on our contracts, right? So we might have one contract that we've updated 9 times. And in order to properly use the subgraph, you know, every time we update it, we have to make sure that new contract is now tracked and that the latest deployed subgraphs are accounting for all of our contracts, right? So in this case, like what happens is we're mapping over, so it'll be like collateral short 0, and then the next one will be 1 and 2, 3, 4 until our most recent one, right? And so yeah, and then in our build script, we map over all of the networks, right? So what you can do is you can pass a specific network and it'll only pick up the contract for that network, or you can pass into the build script. If all is the network, it'll kind of do a loop through and it'll run graph builds for every network, right? And so a lot of people do this inside of the package JSON. They'll have the graph code gen and the graph build commands inside of there. We didn't want to have a package JSON that was like 300 lines of like different commands, because like for each subgraph, you're going to have a graph code gen, a graph build, and a graph deploy command. And then you're going to have different commands for each network because the network's changing. So we thought a shell script is a really nice solution for that, and it's working really well for us. But if you look at our package JSON, it's very simple, right? Like that's it. You do npm run build, and it gets all the ABIs from our contracts. So we have an ABIs folder here, and if we ever change an ABI, so like for example, our exchange rates ABI has changed a lot over time. It's very easy to we just manually change it. So I'll like rename this, and I'll say V246, right? And then I'll run. So then it'll kind of save this, and then when I run this prepare ABIs, it'll get the latest exchange rates ABI. So that's probably very confusing what I just said, but essentially we just need to track all of the ABIs for all of the exchanger or exchange rates or whatever contract we have over time. So a lot of times, like the exchange rates contract will be very similar, but the ABI will change in small ways that are important for the subgraphs. And so we kind of use an automated script to get the latest ABIs. And if we have any historical ones, we just save them under unique names, and those will be committed to Git forever. And they should never be overwritten. But anytime we run this, it'll overwrite like our ABIs with the latest ones. So yeah, so what we do is we get the latest ABIs, and then we run that. Let me go back. We get the latest ABIs, then we run this build script, which will run the graph cogen and the graph builds for either all the networks for that subgraph or for just a specific network for a specific subgraph. And then we have a deploy script, which is very similar, right? Like you can deploy something to every network here. It'll loop through all of the 4 networks we support. So you could say npm run deploy all rates, and this will deploy the rates subgraph to every network, or you could just do it for mainnet. Right, and then kind of what the one is 1 is just the first argument, 2 is the second argument. So the subgraph is rates in this case, right? And then just like in a regular package JSON, you have your access token where you run these commands, right? So this is kind of like very similar to what you would see in like the package JSON for most graph subgraphs. But you can see here, like we use the JS instead of YAML, like I think most package JSONs would look like that, right? So yeah, that is, I think, the high level of most of our changes. I can go into greater depth on certain things we did here and there, but I think like in terms of multi-networks, it's really something that I would recommend people study. Our repo, we have GitHub Synthetix IO is the name of the repository, and then just synthetix-subgraph is the name of the repo. And what I'm showing right now is under the refactor branch. Soon we're going to put it on master, but not yet. So what we're looking at is like kind of like us making changes and preparing for the launch of Optimism, where we're going to have a lot more users, and kind of making it easier for us to test stuff. Like just testing on Codeman is so difficult because you know, constantly like having to update large YAML files, and even using Mustache, like it just wasn't working for us. It wasn't powerful enough. But we really like the changes we've made, and I think they're really good. As we were saying before, probably the biggest challenge we're going to face is like, how do we curate 13 subgraphs on mainnet for the decentralized network launch? And like some subgraphs get more use than others. Do we curate more on some? Do we combine some of the smaller ones and then curate them? You know, there's a lot of incentive problems with an approach like this potentially. So, you know, like we have a lot of people on the team with GRT tokens, and like we do have 13 subgraphs. So like it's really good because the subgraphs are on a bond curve to be the first one to curate. So we can split it up amongst our team when we deploy it, like everyone can curate different ones pretty early because we'll be the one deploying the subgraph. So, and it's advantageous for the community too, because they're going to want to see that we're curating the ones that we think are important, right? So that they know which are the official Synthetix ones. But like, let's say that our subgraph devs like curated on a specific one, you know, they're now incentivized to put more volume onto that one. So if there's like high volume queries like that need to be added, and the developer is now incentivized to put it on their specific one. So it creates all sorts of like weird issues. So one of the things that would be cool that we talked about is if people could curate on like an account versus just a specific subgraph. So like you could curate the Synthetix account, which holds all these subgraphs, but it's not set up for that right now. And I don't think these are major issues. It's just some things to think about, you know, if you're going to do this type of approach.
That's also something we need to come back to when subgraph composition comes into play. How will curation shares behave? Will they have like a cascading effect? How will query fees be distributed?
Right. It's very complicated, for sure. I guess like another point is like we use this fragments thing called for latest rates. So our biggest problem, or just not problem, but our most difficult thing is handling the Chainlink rates, right? Because technically it's its own subgraph, but because there's no composition yet on the network, you can't just have like a Chainlink subgraph that lives on its own. You have to, if you want Chainlink data, it needs to be on the subgraph itself, right? So if we want like the rate of a synth, the price of a synth, it needs to be stored on a specific subgraph. And a lot of our subgraphs rely on prices. So like, for example, exchanges, we need to know the price of, like inside of exchanges, we need to know the price, so the latest rate of a synth, right? So when you do an exchange, you get the rate, you track the amount that you're trading, and then you can put the dollar amount in if you have the rate, right? So it's very useful when we're tracking trades through our platform that we have the Chainlink rates. Also for like our other exchanger subgraph, we use the rates to calculate like our volume partner program. So like if Curve sends us a lot of volume, we want to track it. We want to know how much volume they had, how many fees they generated. And so we do need the Chainlink data in a lot of these subgraphs. And how we solved for that was we kind of created a fragment that is like you can drop it into your subgraph, but it exists. It's like its own sort of it's its own code and it's separate, but you can easily like integrate it in with the other ones. And using the JS system that I showed you, it made it really easy to do that. So like we get all of the data we need for the rates across any subgraph, and we like map over it using JavaScript. And then what we do is we at the bottom we export the templates and the data sources we need. And then if you look inside of like our exchanges.js file, you'll see that we pull in the latest rates right here. And what we do is we put those in at the manifest, and then we also add in all of like anything that are specific to the exchanges outside of the rates here, right? All the contracts we need to track for that subgraph. And then at the bottom, you'll see that we have a manifest now, which has all of the right data sources, but it also includes like the Chainlink data. So you'll see it in the exchanger one too. Like it has latest rates here, right? All the templates. The manifest has it up here. It's from it's cloned into the data sources. So it would essentially, you could do this with Mustache too, but it's a lot harder. So we really like using JavaScript. So now not only can we break up any subgraph into 4 networks really easily, we can also like combine stuff. Like we can take all of our Chainlink data and easily insert it into a new subgraph. And like to do that, it's only a few lines of code, right? So like we require all the rates information, the fragment that we want to insert on top. We clone it into the manifest, which the manifest is basically like the data sources, all like the YAML addresses and contracts. We add on like all the exchanger ones, all the other ones we need for this specific subgraph. And then at the bottom, we just export also the templates for the rates. So we basically can now add Chainlink data to like almost any of our subgraphs with only 1, 2, 3 lines of code. So it'd be 1, 2, and 3 at the bottom. So it's pretty powerful. I think using JavaScript is a lot easier for us than Mustache. I highly recommend people study our code base. Like this is not trivial to do. Probably spend like 2, maybe 3 days just studying our code base before you try to do anything, and understand all the nuances, understand that like we have certain files that are generated by our smart contracts team that you might not have. And so I wouldn't just jump in and do this. I would spend some time trying to understand it. At a high level, I think everyone needs to test stuff. So everyone wants subgraphs on their test nets. Everyone wants their subgraphs to be performant. So if they're on like an L2 where transaction volume skyrockets, they have to keep up with the chain, right? So we use like a microservices approach for that, but is it the right approach? TBD. But yeah, I think like if you have a very large smart contract system, this type of approach makes sense. If you have a new protocol with like maybe a few smart contracts, maybe you're not updating that often, depending upon your proxy architecture, how often you're updating the contracts, you might just be better off using like a simple YAML thing. You know, if you have like a YAML file that's like 200 lines, you can maintain that across 4 networks pretty easily. Once it starts getting to be where like you have like 60 contracts in a YAML file and you're tracking it across 4 networks, it gets really difficult. So let's say you have a proxy that points to an underlying contract, and the whole purpose of doing that is like you're going to swap out this underlying contract fairly often, but you want people to like be able to work with your system, so they're always sending to the proxy, right? The proxy should never change.
Yeah.
Now it does make it easier in the subgraphs to use a proxy, because like you can always just point to that proxy, read events from the proxy. But in order to do that, you have to set up your system so that the proxy is the one emitting the events you need, right? So in some cases, the proxy doesn't emit all the events you need. Maybe it's only emitted on the underlying. So in that case, like you're kind of screwed on the subgraph side. Like you're kind of at the whim of the architecture that you're given, right? And so part of the problem is like Synthetix has been around a long time. So the architectures change over time, but like not everything was set up perfectly where like there's a proxy and everything emits from the proxy and you can just ignore all the underlying contracts, right? So some subgraphs have a huge advantage there if the system is set up appropriately for them. But on top of that, not only does Synthetix have like a long-lasting architecture, so even if we have like that ideal architecture today, where it's kind of just like swapping out the underlying and only listening to the proxy, like we have all of our historic contracts that we want to track, right? We want to track them accurately, want them to have the right data. And then in terms of Chainlink, Chainlink's a whole nother beast. They have a proxy and an underlying aggregator, and we need to track their underlying aggregators, which are constantly changing, but there's no events that tell us when these are changing. So it's actually a really hard problem to solve. And the way we did it is when they deploy these new contracts, they do it from the same address. So, and fortunately, that's a multi-sig address, which is a contract address, not an externally owned account. So we can actually track that contract address. And whenever they do it, they emit this event called execution success, right? And so whenever we see that event, we can track the aggregators. And how we do that is we call this handle Chainlink update. And this handle Chainlink update actually calls this event, and you can see the events grayed out because we're not actually using it anywhere. We're just using that event as a reason to see if there's any new aggregators that Synthetix needs to be aware of, right? And so how we do that is we go to the Synthetix proxy contract, and we get the underlying Synthetix contract, the one that we change out more, not the proxy that all the requests come through. We go to the underlying, and so we get that contract, and then there's something called a resolver that we store on our underlying contract, and that resolver basically is like a cache of all of the addresses in our system. And so inside of that cache, there's this exchange rates contract. So now we're reading from the cache, what's the exchange rate contract address? So we're getting that address, we're binding it to the exchange rates ABI, right? So now we have our rates contract. And our rates contract can read through to Chainlink to get their aggregator addresses. If you pass in the right key, you'll get the Chainlink aggregator for that key, right? So what we do is we do a loop, right? So while we're still, it starts at index 0, right? So when we have synths that we track in our system, they're stored from 0 till the latest number, right? And each one, when you call aggregator keys, which is a method, will return a key only if there's actually an aggregator that's live for that synth, right? So if what we do is we loop through all the aggregators every time Chainlink every time Chainlink releases a new they could not even be releasing a new aggregator. We don't know what they're doing, but there's a good chance they are. So what we're doing is we're mapping over all of the aggregators that Synthetix uses, and sometimes it'll return a new address, right? And what happens is this is our contracts will read through to the Chainlink aggregators automatically, right? So this try aggregators function will actually return the Chainlink's latest aggregator for that synth. So if they've added a new one, we call add aggregator. If it's the same one, it does nothing. If it's a new one, it'll add it to the system. So that's kind of how now we track all of our aggregators. I will say that Chainlink is they have a new contract event that's on their proxy contract, which will say when they've added a new aggregator now. So they're on Optimism, they have that event now. So this little hack is only something we're using on mainnet, and eventually they're gonna update their contracts and emit the events that Subgraph developers need. But you know, you're always gonna need historical data, right? So you're always gonna need a hack like this for mainnet. Fortunately for Optimism, we haven't written that yet, but we're going to be writing that in the next couple of days. It's just like, I think an aggregator confirmed event that fires from the proxy. So yeah, it makes it a little bit easier. Yeah, and we have open source code. Anybody can copy what we did or change it however they want. And you can submit PRs to our repo and you'll get rewarded if you have good code. If you try to port ours over and you notice something could be better, submit a PR and you can be eligible for SNX rewards. Yeah, pumped about the graph. I think it's such an innovative project. I think you know, there's only a few projects that are really like kind of out there on the edge of decentralization and building things that haven't been seen before. And I think the graph is definitely near the top of that list. So I love being part of the community and I'm happy to help out for sure.
Thanks for being on. It's also going to be great listening to you on GRT IQ podcast.
Dude, this was amazing. Thank you so much for having me.